it looks different when it's on the when you screen share. Right. So just a sort of quick overview of what we're going to be covering this morning. So there'll be some sort of instruction from us, some information and some demonstrations and things, and then you'll get some workshop time to be able to do some hands-on practice for yourselves, and then we can answer any questions that you might have, and we can sort of help you get stuck with anything. If you have any questions as we go through, then there's a chat box at the bottom. You can put your questions into the chat and we can answer them through that, or depending on what it is, you can unmute yourselves and we can sort of discuss any questions or issues you might have. And there will be a break later on from the proceedings, and there will be a feedback poll at the end of the session. So just to sort of cover, we've touched on this briefly by mentioning the introduction to BlueBEAR, but just to sort of give you an overview of our training course structure, so that this is really the sort of starting point for using Linux. And after today, you may want to go on and do other things and other things that are relevant to you. So we'll just run through this briefly so you know what's out there that you can access. So this is the Introduction to Linux face-to-face course, obviously. There's also a Canvas equivalent. So if you wanted to sort of go over things again in your own time as a sort of refresher, then there's a sort of equivalent version of this in Canvas for you to access. There are also lots of resources available on LinkedIn Learning, and the university has a subscription to that every member of the university can access. And there are all sorts of things like Python and Linux and Git and loads of things that you can access through LinkedIn. So again, you can choose what's relevant and go through that in your own time if that will help you as well. So that's the first steps area. Then you've got the intermediate. So the Introduction to BlueBEAR course that we mentioned is next week. We do recommend that people attend that to get the sort of the more detailed information about how to use BlueBEAR, running jobs, etc. And then we have software carpentry courses that we use their curriculum. And we currently have Python and R, Git and MATLAB, and they're all software carpentries. And we also do an NVIDIA course as well, which is a one-day course. So there are further steps that you can take depending on the type of research and the software that you need to use. And then we do offer a C++ course as well, which is a sort of longer, more in-depth course and sort of requires more knowledge, so prior knowledge really. So yeah, it's sort of making you aware of what's possible beyond the course today. So this is how the session this morning is going to run. In the first section, we'll sort of just give you a bit of background, a bit about the BEAR team and what we do, and then a sort of background about Linux, and then we'll actually do sort of logging in and making sure everybody can access the system. Then we'll look at things like sort of creating files and that whole sort of issue surrounding that, and then Linux commands and file management. So the sorts of things that you do on Windows, how would you do that in Linux and with BlueBEAR? So that will incorporate workshop 1 and workshop 2, where you get the hands-on practice. Then we'll have a break for a few minutes. We'll all need a comfort break by then. And then towards the end of the session, Aslan will take you through section 4 and 5, which is the things like file permissions and running a program. And then we'll just do a little summary of the other BEAR services that are available to you, because there's much more to what we have than just using BlueBEAR. So that's how the structure of how things will all work. So we touched on in the introductions about why people are here and what they're hoping to get out of the session. So these are the learning outcomes that we have sort of established for the session. So hopefully by the end of it, you'll be able to tick off all or most of these that you can now do. So setting up your computer for accessing BlueBEAR. So we've already talked quite a bit about the remote access service and things. So you actually know how to log in, and you can do that successfully. You want to manage directories and files, so you can actually manage the research data that you have. To understand and use some basic Linux commands, and it's certainly sort of scratching the surface really of Linux. It's a huge area, and we're just covering the basic things you need to know today. How to create a job script, that's towards the end of the session, and then how to set permissions on the script so that you can actually run it. So as we go through, bear in mind, these are the sorts of things that we want you to have achieved and to be comfortable with by the end of this morning. Okay, so let's jump into section 1, and let's just start off with a bit of background. What is BEAR? I suppose it helps to know what we're actually talking about here. And that's our website at the top there. And there's tons of information on our website with sort of descriptions of our services and detailed instructions and videos and sort of step-by-step guides and all sorts of FAQs and things. So there's a lot of stuff we can refer to on our website that we won't go into today, but it's there to support you and help you. So BEAR is the Birmingham Environment for Academic Research, and it's a collection of services that are there to support researchers with managing their research data and processing their data. So the HPC is the high performance computing, which is the BlueBEAR part of it, but we have a range of other services as well, and we'll sort of go into those in more detail towards the end of the session, but just making you aware that there's more to it than just BlueBEAR, basically. BEAR services are free at the point of use, which basically means we don't charge you to use BlueBEAR. There's the sort of funding comes from other sources centrally in the university, but so the basic storage and BlueBEAR you can just use for free through BEAR projects, as we'll see in a second. So as far as BlueBEAR itself is concerned, so this is the high performance computing, so the supercomputer that processes jobs faster than your laptop would or your computer would. And as some of you have already mentioned that this morning about wanting to sort of do things faster and getting your results and your data back faster. And hopefully that's what we're here to achieve with BlueBEAR. So users need to register to use the service, and I've registered you for today's training course. After the course, you need to be attached to another BEAR project, because at some point you'll be removed from the training project because it's obviously a short-term thing. So you'll need to have access to another BEAR project. So either your supervisor or your PI can add you to a project, or if you're a PI yourself, you can obviously create a project and sort of add yourself to it. But you'll need to have something going forward to access. And you can be attached to multiple projects. So it's not just about one, you can have as many projects as you sort of need to have to access. Projects need to be created by staff, so PhD students can't create projects. So that's why I said about it would need a supervisor to create one on behalf of a PhD student. And they by default, they're sort of set to exist for 5 years. Projects are used to account for time on the cluster. So that's sort of, you have all your things that you run through your project, and then that's how it works. So you do things on a sort of project by project basis, basically. And there's just a link there for information about registration. So even though I've done that for you today, that's just in case you needed to pass that on to other people in your group, or just for reference. This workflow diagram I think is useful because it helped me to sort of understand the process of what you're doing and why and how it all fits together. So let's take the fact that you have some data, which hopefully you've got on the RDS, which is our research data store. So that's a space where you can store your data, and you can have up to 3 terabytes of storage for free on that. So say you have some sequence, you want to process that on BlueBEAR, you'd store it on the RDS, and then you would have software that you want to use to process and do something with that data. So you would write a job script, which is what we'll be having a look at later on, and you're telling BlueBEAR what you want it to do with that data and with that software, and how you want it to sort of all be processed and how much time it would need, etc. So you do the job script, you send that to BlueBEAR, and it runs the job. Depending on whether it works or not is what happens next. So hopefully it does work. If it doesn't, you sort of go back round in the loop, edit your job script and try again, sort of do that until it actually works. Once it does work, which you move down to the sort of bottom bit, where it's, does it need any post-processing? What output have you had? Do you need to do anything else with that data, or is that data set then what you need to analyse? So you may or may not need to do more post-processing. If you do, you may need to run more jobs based on that output that you've got from BlueBEAR, and so the sort of cycle continues. And then you can run the view the results in the RDS, the research data store. So I think it's thinking, right, here's my data. What do I want to do with it? How is it going to be processed? Which software am I using? And then what do I get out? And then what do I do with the output at the end? So hopefully that will give you that sort of overview of where you start and the journey that you take to get to the results at the end, which is ultimately what you're looking for to progress your research. Okay, so let's talk about Linux a little bit now. So this is the interface that we use for BlueBEAR and how we connect to it, and we give the computer the commands to tell it what to do. Basically, it only does what we tell it to do, and it has to be sort of very specific, and you have to do things in a certain way, otherwise it's that computer says no type response. I think it's worth pointing out that Linux is a massive subject. If you bought a book on it, it would be sort of that thick or something. If you Googled it, there'd be masses of stuff out there. So we are only covering the simple basic stuff to get you started with BlueBEAR today. There's way more to it that we won't cover. And also there can be multiple ways of doing the same thing. So if we ask one of our research software engineers to do something, they may take a different approach, because they've got experience and background knowledge and things, that they would just do it in a certain way. So if we do something in a certain way today, and you've used Linux before, and you might think, oh, well, I wouldn't have done it like that. That doesn't mean it's necessarily wrong. It's just that there can be sort of alternatives that will still work and still get you to the same sort of point. So don't necessarily be put off by that if you would do something slightly differently. So to access BlueBEAR itself, we've talked about registration, so you're registered for the training course today. So you need what's called an SSH or secure shell client to be able to connect to it, so that's the way that you sort of make the connection with BlueBEAR. So if you're a Windows user, you need something like PuTTY, and there are sometimes people come to the course and say that they've got another tool that they prefer to use, which is fine. You know, we don't prescribe that it's PuTTY. It's just that that's what we use to demonstrate with, because it's a sort of simple tool to use. So if you have something else that you have already used with Linux, then that's fine. If you're a Mac user, Terminal is built in, you can just use that. You don't need any separate software. So if you're on campus, you can just log directly in. If you're not, if you're off campus, you need the remote access service. We've already discussed that. And you would just use your standard login, username and password as you would for email and other university systems. One of the things that sort of throws people, I think, a bit and makes it a bit of a steeper learning curve is that the interface is command line, and we'll see that very soon, where you basically just get a sort of command prompt, and people are so used to graphical environments, and this is the sort of total opposite of that. So I think it can seem a bit alien to people at first, but yeah, we'll sort of go through that, and you get used to it. It's just that initial sort of thinking, I'm just seeing a dollar prompt, what do I do now? But that's what we're here to look at. If you're using graphical applications, so maybe things like MATLAB, where you have graphical output that will occur, we have a thing called an X service. So there's a tool called Xceed, which will actually allow you to see graphical output. And the Mac version of that is Xport. We won't actually be covering that today, and there's information on our website about that, but that's if you happen to be using graphical applications. So if you're logging in from a Mac, do we have any Mac users today, just out of interest?
Yeah.
Yeah, okay. Usually we have one of our team here who's got a Mac, and then she can sort of show you how to do it on a Mac, but hopefully you'll be able to do it from the instructions there, because we're myself and Aslam are both Windows users. But yeah, that's what you need. So you go into Terminal, and then you've got the SSH, and then your username, and then the 172.31.11.62. That's the IP address of the virtual machine we'll be using for today's course. So for any Mac users, that's the bit that you'll be needing to type in. The bit with the IP address, that's only for the training session. So after today, if you're using a sort of real project, or if you do the introduction to BlueBEAR course, then you would use the bluebear.bham.ac.uk bit, so that the IP address that's just for this training project that we're using today. So hopefully the Mac users will get logged on. We'll deal with that if not. Because what I'm going to demonstrate is how to actually use PuTTY, so that everybody else that's Windows users can actually get logged in using PuTTY. So that's a screenshot there of what PuTTY looks like, and I'll do that myself in a second. As I said there, the host name, the 172, that's the virtual machine training server. And the instructions are on the website there. So what I will do now is I will just show you Hopefully you can see that that's my real putty window there. So I've already connected to the remote access service, otherwise I wouldn't get anywhere. So what I'm going to do is in my putty window here, where it says host name, I'm going to put in the 172.31.11.62. As I said, if I was using the real BlueBEAR, I would just use the bluebear.beham.ac.uk. In the saved sessions box, I'm going to put in, I'm just going to call it BlueBEAR. I can't call it training because I've already got that. I'll call it training too. So you can save that as a session. That's basically so that you don't have to type it in every time if you lose the connection or you come in and out or whatever. You don't have to sort of enter that every time. So put your host name into there, you give it a name in there, it doesn't really matter what you call it. And then you do save, and then it will add it to this list here so that you'll have it there for future reference. And then next time you come back into Putty, you just click the thing that you want to connect to and then do load, and then you can open it from there. So you just taking it a step basically. So I'm going to say open now, and it will, that will give me a putty window, and that's what I'm connecting to. You can see it at the top there and the top bar. And basically I need to log in with my normal username and password. The username needs to be in lowercase. This is one of the things we'll come on to with Linux, is that it's case sensitive. So it doesn't recognise if it's expecting a certain case and you use the wrong one, it just won't recognise it. So usernames need to be lowercase. If there are any uppercase characters in your password, then you do need to do that. So the password has to be the case that it was created in. What's weird about the password is when you type it, you don't see anything. So you've got the green prompt thingy, I don't know what that's called there. When you type it, nothing happens. So you don't see any asterisks or anything. So you think it hasn't typed, or you don't know how many characters you've typed and things. So I think that looks a bit odd. So I am typing now, but you can't tell. And then you press enter and you hope it works. Aha, there you go. So it has worked. So yeah, don't expect the password thing to actually show you anything. And then you hit enter, and there you are into. So I'm now connected to the training virtual machine, and that is the command prompt that Linux will give you. And that's the bit where you think, oh, this is different. What do I do now? So what we need you to do is we need to make sure that everybody can log in, basically. So if you're off campus, get into the remote access service first, otherwise you won't be able to do the bit I just did. And then open and set up Putty or terminal if you're a Mac user, and then log in to the training virtual machine, which is the 172.31.11.62. So I'll sort of start again so I can show you. So yeah, everybody have a go at doing that. And then if you've got any questions or you're stuck with anything, then we can help you to get you to that stage. Is everybody okay with that? To continue the recording. Right. So we'll come back to Putty and Terminal later on when we come to do some hands-on, but I will just talk you through a few bits and pieces now to do with how Linux works and how you would think about using your data. So creating files is the first section, and we're going to talk about the command line. So once you've logged in, you've actually seen the command line. So you get that lovely dollar prompt and not a lot else there, which is a bit scary. So basically there, you type in commands, and that's the thing called the shell, and the one that we use is called bash. So somebody says, people sometimes say they know a bit about how to use bash. And that's basically how it sort of interprets the commands that you're giving it. So it will sort of look at each one and act on whatever you've told it to do, sort of very, very sort of specifically. As I mentioned earlier, commands and things that you type into Linux are all case sensitive. So if you do something that's in the wrong case, Linux will just not know what you're talking about. It will look for the case, and depending on what it's expecting to see and what you give it, some things just don't work. So that's a sort of a trap that you can easily fall into. So do bear that in mind. Another one that's easy to get wrong and causes problems when you're beginning, you think, why is this not working? Is if you have a spaces in the wrong place. So either you have a space where you shouldn't have one, or you don't have a space where you should have one. And so basically, if the spaces aren't as they need to be, again, it won't understand and it won't be able to do it. So I think the message on all of that really is, it's sort of less forgiving than something like Windows. It has to be exactly right, otherwise the computer will say no. You can copy text from other places, such as, if you've got put into a command, but it has to be plain text only. And we'll talk a little bit about how you can convert text later on. But things like if it's from Word or something like that, Windows will put in weird end of line breaks and stuff like that Linux just doesn't know what it is. So it has to be just plain text that you can, if you are going to copy and paste into Linux. Directories and files, I think the point of this is to understand how it all works in a Linux environment. So unlike Windows, you don't have things like the C drive or the D drive or the K drive that you would have on your own computer. So they're called directories. So in Windows, I'll call them folders. The term's sort of interchangeable really because it's the same. But yes, so they're directories, and you have a thing called the root directory, and then you have everything else sort of stems from that. So you can create your own directories, and we'll see how to do that shortly. So they're basically like subfolders, and that's where you can store your data. So it's knowing how to do this, because obviously sort of file management and how you manage the output that you get from BlueBEAR is really important. So you don't just have a sort of mess of stuff everywhere, and you know where it is, and it's likely that your project will be shared with other people. So whether it's your PI or your supervisor or other people in your group, it needs to be clear what's where and how to find things. Otherwise, you're just going to make life harder for yourself. So that's why we're going through this to sort of get a picture of how to set that up. So one of the things that you have is your home directory. So it says that RDS/homes, and then U is for the first letter of your username, and then it would have your actual username. So that's 20 gigabytes maximum space for each person. That's not where you would expect to put your actual research data and your output and things. That's for things like settings. So don't put things into there, because that's a limit. It's not sort of project space. It's your home area. So any data, job scripts, output files, etc., should all be in the RDS, the research data store directory that's associated with that project. So you can see there's a path for the RDS/projects, and then the start of the P's for the start of the project, whatever the initial of the project title is, and then the project title itself. So it's getting your head around how directories work. And obviously, once you have those, then you can put whatever files into that you wish to. So there's a thing in Linux called a path. This is our attempt to, it's quite difficult to come up with jokes to do with Linux and computing really, but this is our only attempt to have one. So the path is not where you walk, it's what's sort of set up in your environment. And so if you typed in echo path, echo $path, it will look to see the programs that are set up in your environment. And the reason we're telling you that is that if you get a command not found message that it gives you, you might think, well, what does that mean? It means that the program isn't in your path and therefore it's not available to you to use. They should already be set up on BlueBEAR, so it's not very likely you would get that, but just in case you saw that and wondered what it meant and what it was about, I'll show you that later on, where you can actually see how that works. Notice that path is in uppercase, so it's one of those things where it has to be in uppercase, the word path. Otherwise, if you do it in lowercase, Linux will say, I don't know what you mean. So now we know a bit about directories and how they're structured really. What you would want to know then is creating files. So I tend to think of all this in a Windows context, because that's what I'm just used to using for so long. So it's like, right, how would I create a folder or directory, and how would I create files? And then I've got stuff to populate the files with. So in a Linux context, you can create files in using a thing called Nano. Nano is a text editor in Linux. It's a very simple one. There are various other ones, but this is just to show you the basics of how to use it. If you prefer to use another text editor, then that's fine. The sort of outcome is the same as if you've created a text file. So this is just an example of how to do it. So it runs within the terminal window that we've just seen, so the PuTTY or terminal, and you've basically put your text in. There are commands that allow you to save it and give it a file name, etc. And then that becomes part of your project data. So I'm going to show you now. I've made that font bigger, so hopefully you can see that. So I've logged into to the training project here. I'm going to type in Nano at the command prompt, and that now loads Nano. And the reason that we're showing you this is you could put your whatever data you need into here, but you'll also use this for job scripts later on. So this is where you will create your job scripts. So I can type in whatever I need to into here. I could paste in text if I've got some text from another source. I could actually, plain text is what you would actually want, but I would paste it into here if I needed to. So put whatever you need to into there, and then at the bottom, I'm hoping you can see those commands. So things like previous and next. If you've got you might have a long document. You can cut and uncut, which is cut and paste, I suppose. When you've done it and you want to save it in Nano, it's called write out. It doesn't say save. Who knew? So what you have to do is you've got the little pointed arrow thingy, which is the control key. So on your keyboard, you do Control and O, which is write out. And then at the bottom, it asks you for the file name. Now, what we recommend is to have, it's better to have lowercase because it's just easier to get the case right then. Also, don't have weird characters in there. So in Windows, you could have massive long file names and whatever you want in there, and it probably says okay. But it's best not to have odd characters because they might mean something else in a Linux environment. And also no spaces, that's quite important because Linux treats spaces in a different way to the way that Windows does. So no spaces in file names is best. So I'm going to call it testing one. You put your file name into there, press the enter key, and it's written. And it tells you that it says wrote one line at the bottom, so you know that it's saved. So at that point, I can say, yeah, that's my text file. I can come back and edit it, add to it later if I want to. To exit Nano, you use Control and X, which is tells you at the bottom left there, and it will take me back to the command prompt. So I've gone into Nano, created my text file, put whatever I wanted to in there, saved it, and I'm back to where I started. So that's how you can create files, and that later on you'll use that to do a job script. So that's what I've just done there. There's just a screenshot of what Nano looks like. And as I say, if there's other things that you can, if you've got a preference for another tool, that's fine. So the next thing we're going to have a quick look at is some of the basic file commands that you would need to use. So once you have files created, it's sort of manipulating them, seeing what you've got, where is it, etc. So the first one you've got is ls, which is to list the files, and it'll show you what you've created, where you are in the structure, the files that you have. If you want to see more detail about them, you can do ls space -l, and the space is important, as I mentioned earlier, to get the spaces in the right place. So that will show you more information about what you've created. CD is to change directories. So that's how you move between different directories that you have. So in Windows, you would double click on a folder and you would go into that folder and see what's in it. In Linux, you do CD for change directory to the, and then put the directory name that you want to move to. And PWD stands for print current working directory, but it doesn't mean print, it means just show you where you are in the structure. So I will run through some of those now. So if I do ls, you'll see there that I've got various things showing. The ones in white are files, the ones in blue are directories, and the ones in green are scripts. And it's just showing you that it's different things. It's the color is just so you can see the different types of things, but that doesn't really tell you a lot. So that's where ls space -l is more useful in many ways, because it will give you detail. So it will show you when it was created, and that might be relevant, so you can see how recent the file is, etc. You can see, I'll scroll up a little bit here. Yeah, you can see the date, the name, who owns it, etc. The bit on the far left will come to that towards the end, which is to do with the permissions on that item and who owns it and what you can do with it. So we'll cover that later on, but that's what you get if you do ls-l, is just to see that detail. If I do pwd, it will show me where I am in the structure. So I'm currently in my home directory, so it's got RDS homes and then my username. So that shows me where I am in the, if I want to navigate around. So as I said earlier, you've got here, the blue ones are directories. So if I want to move into, say, the testing directory, I can do CD space and then testing, press the enter key, and it will, you can actually see there this sort of that's changed there, so you can see you're in the testing directory. But if I actually type in pwd, it will show me that's where I've moved to. So you can get a sense of where you are in the structure, because it's not as obvious as in Windows, where you just see your folders and click on them. So that's what we just covered there, is some of those basic commands, and you'll get a chance to have a play with those in the workshop and experiment with creating things and see where you are in the structure. Some of the other things that you might need to do is you've got some, when you're creating files, sometimes you might have some quite long files. And also when you're running jobs on BlueBEAR, you might want to see how the output is sort of being created, to see whether things are working in the way that they should be or not. A job that runs for a long time, and you want to make sure it's actually doing the things that you want it to do. So you've got here examples of cat is to actually view a file. So if you do cat in the space in the file name, and it will actually show you what's in the file. So if you've created a text file or a job script, you can actually use that to view the contents of that file. If you're running a job and you've got some output being created, you can use head space and then whatever the file name is where the output's been created, and you'll actually see what's being produced in output at the start. So that's the start of the file, and the opposite end of that is at the end of the file. So tail and then the file name will show you what's being produced at the end of the file. So sometimes that can be useful just to check that things are working as they should be. If you've got a job that runs for 10 days and then at the end of it you find something was not worked properly, or it wasn't what you expected it to do, if you've sort of had a quick look at it while it's sort of in progress, then you can sort of see if you can find out sooner if things are doing what you want them to do. So the command syntax is really related to this whole issue of the computer will do exactly what you tell it to do, and there are lots of sort of details behind that. We've got the command at the bottom in the table. You've got the command, so what you're telling it to do. So things like ls that we just saw, to list the files and the directories and the scripts. The options then, so that there are various options associated with that command, and there's a manual that you get in Linux, and it will actually sort of tell you what the different options are. So if you weren't sure of what, say we're scratching the surface today, what you can do. But if you're not sure which option you need, you can go into the manual and it will explain the different options and what they do. Or you just Google it, because there'll be lots of instructions and information and guidance on what the different options mean and how to use them. And then the argument, for example, could be the file name. So you want to run a command on a specific file. So it's the sort of structure is key for things to work in the way that you want to. If there's a bit missing, then that's where it won't do what you want it to do. So sort of just laying out how, explaining that the syntax is important to get it all to work properly. So I just mentioned that the manual, that's an example there of what the manual looks like. There's a lot of detail in it, and I'm not sure it's the easiest thing to work with, really. So Googling is probably easier in many ways because you'll get more explanations. But yeah, if you want to look at things like an argument, then look in the manual, and you at least see, like, there you've got a -a, and then what that actually is. So it's worth having a look at, and then you could always take that to Google to look at more detail or what other people have done to make something work. And there is that's our only other Linux joke, is that there is a manual entry for the manual, which is quite sad that there's actually a manual about the manual. There you are. I'll actually just quickly show you. If I do man ls, what will that tell me? So so this is telling me what ls is for. So list directory contents, and then it will tell you what all the different arguments. So what -a means and what -c means. Notice I'm pointing at the screen. You can't see me pointing. Notice that there's a -c, a small c, and a -c, capital C. So that's going back to reinforcing that message about case sensitivity. So who knew that there are so many options to do with ls? Wow, I think that's covering most of the alphabet there, which is actually quite scary. I didn't know there were that many things. So there's a lot. So maybe useful, maybe, yeah, it's worth knowing it's there, but Google as well. And then to get out of that, you just press the space bar to page down the manual, because you're likely to get lots of pages. And then you can use the Q, press Q on your keyboard to get out of the manual, and it takes you back to the command prompt where we started. So knowing how to get help is important. This, I think, is one of the most important slides, in the sense that we were talking about efficiency earlier, and how to do things in the most efficient way. And people that have used Linux a lot, they just sort of muscle memory on the keyboard, but they will also use lots of keyboard shortcuts and things like that to speed up the process, and they're just doing so many things repeatedly. So there's little things you can do to make that sort of thing easier. So things like pressing the up arrow on your keyboard, you'll see the previous commands that you've used, and then you can rerun them, particularly if you've got sort of something quite long that you've typed in and used before. There's two advantages of that. One is that you don't have to type it in again, and just takes more time. Also, it means that you're not going to make a mistake in it. If it's something you've used previously and you know it works, then you're not going to make a mistake, because obviously typing things out, you can make a typo, space in the wrong place, etc. So reusing something is it will work. The history command will show you the previous commands again that you've used, and you can just pick something from before and rerun that as well. So shortcuts are always good. You can press once you've started typing something, you can press the tab key on your keyboard, and it does a thing called autocomplete. So it will say it's a file name or a directory name, it will actually sort of complete the rest of it for you. So again, it's sort of just cutting corners, really. So pressing the tab key, so it just speeds up that process. And again, it means you won't make a typing error. If you go into something or you get stuck and you don't have the command prompt anymore, so you can't actually give BlueBEAR any commands, and you think, well, what do I do now? I'm kind of in a sort of dead end. You can use usually the Control and C keys together, or Q, will take you back to the command prompt, and you can carry on doing more commands. You've got the command for CD, and then the curly thingy is called a tilde, which is next to the enter key on the right hand side. Doing CD space tilde will return you to your home directory, so you might have moved around in the structure, got yourself lost, or you might just want to jump back in one step back to the home directory. You can do that. You might have done loads of things and you've got loads of stuff on your screen, and you just want to sort of fresh start, and you can type clear and it will take you back to the command prompt and just wipe the screen with the other things that are on there. And copying and pasting is interesting. My sort of muscle memory is to do Control C, Control V. I had to think about it then, even though it's muscle memory. Yeah, Control C, Control V to copy and paste. You can't do Control V in Linux. You get a weird, something comes up if you do Control V. So you have to remind yourself not to do that. So you copy it from wherever else on your computer, and instead of doing Control V, you have to right click your mouse button at the command prompt, and then it will paste it. So that's instead of doing Control V. So I'm going to quickly show you some of those now. So things like if I press the up arrow, you'll see what I did before. So man ls was the last command I typed in. PWD I typed in, CD testing, etc. So I can just go through those and reuse them. If I do history, it will show me the previous commands that I've used. So there I can see what I've used and what and remind me of what I've used and maybe why I use it, and then I'll use them again. I can, if I do clear, that will wipe all that away and just give me a sort of fresh page at the command prompt. If I do so if I do cat, and then let's try so yeah, so I started typing cat, which is to view something, to view the contents of a file, and I've started writing out, and this isn't a very good example because it's a short file name, but if I do out, and I've only got one thing there that starts with the word out, but if I press the tab key, it just finishes off the rest of the words, so it puts in the out file bit, and then I can just view. So that's what's printed on the screen there now is the contents of the file called out file. But yeah, just pressing the tab key will actually auto complete that for me. What else do we have? And then I can do if I do clear again, and then if I do CD tilde, that will take me back. So I was in testing, and I've now gone back to my home directory. So these are the sort of things that you can have a go with when it comes to the workshop part. So, but it's just these little tips and tricks can actually be really useful, save you time, and just you'll have fewer mistakes because you're using things that have worked before, etc., and auto completing names. So I think that's all useful stuff to know. Okay, so file management, we've talked about creating files. What you also might want to do in order to structure and manage and organize your content is have directories, so like Windows folders. So to do that, it's very easy. You've got the mkdir space, and then whatever you want the directory to be called to create one, and then to remove one, you use the rmdir and then the name. The removing only works if it's empty, and with Linux, it's one of those things that you're not necessarily expecting if you're a Windows user, is that it doesn't, you get those sort of boxes saying, are you sure you want to do this? And Linux doesn't do that. It says, you've asked me to do this, fine, I'll do it. So you don't get sort of warnings and things. So if I did mkdir and called it test2, so mkdir space and test2, and then, oh no, I've already got test2. Maybe I'll have test3 then. There we go. So notice that I've got an error message saying it couldn't create directory test2 because I'd already got one. So I've done test3 instead. And that's another Linux thing that you get used to. is that if it works, it just takes you back to the prompt, and it doesn't, you know, give you a confirmation or sort of do anything. If it doesn't take you back to the prompt, you get some kind of message, then that usually means that there's a problem and it hasn't worked. So going back to the prompt without any other messages is a good thing, because that means it's done it. So if I now do ls minus l, I'll see, oh, there's my test 2 and my test 3. Oh, test 2 was a file. Yeah, so so that's, yeah, you can see that it exists there now. Some other management type issues. Another way, so we created a file in Nano, but you can also do touch and then space and then the file name, and that will create an empty file, and then you can just populate that with whatever data you need to. If you want to remove a file, you can do rm space and then the file name, and it will remove it. It's one of those things where, unlike Windows, there's not a recycle bin. So once it's removed, then it's removed. There are ways that you can sort of retrieve files from a snapshot and backups and things, but yeah, basically think of it as there isn't a recycle bin. To copy a file, you do cp space file space and then the new file name, and it will create a duplicate of your file, so copying it. And if you want to move it, which basically renames it, then you've got the mv space file space and whatever the new file name is. So the sort of things you do in Windows by right clicking and manipulating it from the menu, this is the Linux equivalent. So to create and copy and move. So it's just so you know how to do that kind of thing when it comes to file management commands. But you can have a practice with this in the hands-on session. I mentioned earlier about Linux and Windows not being friends really, or not being doing things in the same way. So if you have a file that's been created in Windows and it has, you know, weird characters and spaces and line breaks and whatever that Linux doesn't understand or doesn't like, then there is a way that you can sort of make Linux by using this DOS to Windows converter. So it is possible to sort of make it something that Linux can use. And as I said earlier, we've shown you Nano because it's a simple tool to start with, but there are lots of other editors, and if you ask the different research software engineers, they'll all have their own preferences for what they use. So yeah, use whichever one suits you. Some of them are more complicated than others, but it's ultimately the preference that you have is fine, because what you create, the end result will be the same. So things like Joe and Vim and Emacs, and there's lots of others, but yeah, use whichever you prefer. So if you want to edit files, so you've created it, there's content in there, it's already existing. If you want to, we've seen how to view it actually by doing cast space and then the file name, and you can actually see what the file is. But if you want to edit something, you can go into Nano. So if I did, so if I do Nano space and then test, well, this is another first text file in Nano. So if I wanted to go into here and then put something else in, so I can just amend whatever I need to amend in here, and then you need to write it out again. So save it, which is the Control and O. You can keep the same file name by pressing enter, and then that's now amended that file. So that's how you can just go back in via Nano and update it. And then the control key and X to come out of that and to go back to your command prompt. So it's knowing how to edit something that you've already created. And you can see there's other commands in Nano, so Control K, Control U, they're all at the bottom of the screen and they all do different things. grep is an interesting one. So this is something I would use a lot in Windows to find things on a page. So I would do Control F and search for something on a page and it will find it for me. The Linux equivalent of that is to use grep. So it's searching for, it could be alphanumeric or numeric characters. and you can look for, if you're looking for a particular term, or something in some output that you've created, then that's what it will help you to do. So if I do go to testing, and then if I do grep, notice that the README file is in uppercase, so you have to, as I've said many times about case sensitivity. So if I do that, it will actually find, hopefully you can see that it's showing you red where I've searched for the word bear in the file that's called README. So it's showing me, sort of highlighting in red where that term is displayed. So you're basically using it to find the instances of something in a file. So it's like Control F in Windows, and you can have a play with grep yourselves in the workshop part, just to see what that does. I won't give you a spoiler on that one. We now have a video before we get to the workshop part. This is this is a cautionary tale on what can happen if the wrong command is used. I'll say no more than that. Can you hear it?
When making a film like Toy Story 2, we use a bunch of Linux and Unix machines. On those kinds of machines, there's a command, rm star, that removes everything on the file system as fast as it can.
Have you ever accidentally dropped something out of your pocket while the toilet is flushing? That's rm star. Somebody had run rm star on the drive where all of the Toy Story 2 files were kept, and things just started to disappear.
Woody's hat disappeared, and then his boots disappeared. And then as we kept checking, he disappeared entirely. Woody's gone. Seconds later, looking up, the rest of the characters on the show, Buzz, Potato Head, Ham, and Rex, had all vanished. And soon after that, whole sequences, Toy Barn and Andy's room, were disappearing off the disk drive. Right in front of our eyes.
If you had 20 or 30 people working for a solid year, you could recreate all of that work erased in probably about 20 seconds.
So I grabbed the phone, transfer me to systems, So they transferred me to the systems group. And I said, unplug the machine, just pull it out of the wall. Pull it out. But we can't pull it out of the wall because pull it out of the wall, pull it out. Plug the machine back in, take a look at it. Wow, a lot of the film's gone. In fact, most of it. Okay, we better tell Galen, technical director of the film.
I remember thinking, wow, this is really bad, but no worries. We're going to get our backups, and
we realized that the backups we had were actually bad.
What do you mean backups have failed for the last month and we don't have any backups?
At this point, Galen mentioned to me in a meeting that she thought she had a copy of the film at her house.
So as a mother who wanted to see her children, I needed to have a computer at home. And so I would copy the entire film to my computer.
We got the machine, wrapped it in blankets and pillows, and put seatbelts all across it in the back seat.
Talk about a backseat driver. Slow down. Oh, easy, careful. Don't. He was rocking and, mumbling to himself and coaching me along.
I back to Pixar, and 4 or 5 of us carried it in like you would an Egyptian pharaoh. Okay, boot it up. Machine turns on. Oh, look, there's the movie.
Thanks to Eli, my newborn baby Eli, and my need to work from home, we had a backup of Toy Story 2.
Bing, bing.
Yeah, so that's a cautionary tale. We did actually have somebody once that decided to type RM star just to see what would happen, and I think it shouldn't actually work on our system. But yeah, I think the point of that is that it's being, or as we said at the beginning, having the confidence in what you're doing, or checking, or do to the best of your knowledge, doing what you should be doing to avoid any issues with losing data and things, because obviously that's not what we want anybody to do. And I should also point out that our systems team don't sit with their feet up waiting for a phone call. They're much busier than that. So that was just a little sort of light-hearted look at, and we do have backups of data as well, I should point out. So that's we can tick that box to say that we definitely have that covered for you. So where are we? Yeah. So we now have the workshop part where this will be sort of, I think we'll probably take the half an hour to be able to have a break time, but also to have a play with what we've done, what we've looked at so far. So we have some, a bit Blue Peter style, we have some files that you can copy. We need to, yeah, we'll put that in the chat, because if you copy it from the PowerPoint, weird stuff happens, or it doesn't copy it in, it's that Windows and Linux thing that don't like each other. So we'll put it in the chat and hopefully that will work. But basically you can copy those files and you've got some pre-prepared content that you can have a play with. So you can use cat to open a file and have a look at it. You can, so you can look at the sample files, you can create your own directory, you can have a go with Nano, you can edit some files, you can view the files, do PWD. So the types of commands that I've already shown you, have a look at those, work through the content in the testing directory that you can copy, and then create your own things as well. So you're having a play with all of that. If you find that all really easy and you can do it in 5 minutes, then there are some advanced exercises in our Canvas course as well. So that will take you sort of a bit further on. But start off with all of that. We'll be around to answer any questions. So if people have had issues with the VPN, etc., we can have a look at that. But so if we restart at, we'll check in with people at about sort of 20 past 11, I think, to see if we can sort of restart at 20 past, 25 past. So you've got that time to have a break and have an experiment, and just to start to feel comfortable with having a go with things on the command line. Okay. So any questions, put them in the chat or mute yourself, and we can deal with that.
There's been a few people who had some issues. Okay. Right. If you this part will it's quite we're just going to cover over the stuff we want to try and understand regarding about file permissions, how to run your scripts, how to actually edit a script, put something in, run your scripts, and see what happens. So what we're going to try and do first and foremost is just cover over the little bit of file permissions. So what are file permissions? File permissions on a Linux system, on each file and directory is assigned access rights for the owner of the file. So if you've created a folder, you own it, and so the permissions are set up so that you can read to it and write to it. There's another section on there called that. So you've got files for that on files, but with directories, which are, what happens is you get access to reading on it and writing on it. And also you should have access to traverses to actually go into the directory. So that's for you and yourself. Now, for members of the group within your team, they will have different access rights depending on how it's been set up. So rights can actually be assigned to each read a file, write a file, and execute a file. For execution permission on a file, you have an X on it, which we'll cover later, just in a minute. But for X on a directory or a folder, remember, I use directories the same as Debbie uses folder. So in Windows terminology, it's a folder. In Linux, we call it a directory, but you can use it in either. You can use it for either file. Oh, sorry, you can use it either term for each one. X will give you the ability to go into the folder. So when you look, so just going to go through trying to do an ls-ld. Now let me show you my screen. So that's, I hope you can see this. So if you type in ls-ld, now you can ls-ld. So what I've done is gone into my home directory. So in here, I've typed in ls-ld in my home directory. And there you will see the folder directory itself, this here itself. So let me just clear that again. Use the up arrow key to get my folder. So these permission here, if you can see on there, there's the information there that we're most interested in. So what are we saying? So we're saying that when we type the ls-l, you'll see the permission. So what does that permission look like? So this is the set here under the permissions here. When we look at ls-l, you will see that this is the username and group of that person. So I own it, so it's my username, and this is the group I belong to. This will show you the size of the file. This is will create when it was last created or in the respect of the directory. So this will show you the last time the file was accessed. But if it was a directory, it will show you when the folder was actually created. And then it'll be the file name or directory. Now, there's other ways of actually looking at that file. So as Debbie showed you in the last, there's ways of looking at that using the commands, the options. So if you do ls-l, obviously you'll see that. But if you type in ls-l HA, I think. Now what you'll do is if you see the difference here, A shows you hidden files, but on top of that, the most interesting part of this is this section here. It will actually give you a human readable form regarding the size of the file. Most of the files, if they're small, they'll give you in bytes, but this will actually give you information using characters like 4K. Values like this are in bytes. I don't think I've got any larger files, but there'll be megabytes for M, G for gigabytes. So how do we break up the permissions itself? The first 3 characters. So if you disregard the first part here, which is defined for directory, if you look at the first 3 characters, this is for all the user stuff. That's you. So you are allowed to read, write, and execute. So you can run the programs. This section is for the group itself. So this is set to read, write, execute. And this is set for others. So anyone else on the system itself can read, write, execute. So obviously when we set up our systems, we allow you to do whatever you need in your folder and your directories. And if you've got a research data stored, then read and execute will be available for that directory, so people can go in, and maybe it'll be write access. So depending on how it's been created, other people will be able to go into that directory itself. But because of the fact that we are security minded in that we want to make sure that your data in your home directory, only you can read itself, no one else. Even if you give permission, we stop other people from accessing it. With respect for research data store, your folder itself, your whole group will be able to read, write, and execute in that whole directory itself, unless you make specific permissions so that you kind of limit who can actually access it. Next, what you want to do is just look at scripts. Scripts, basically what my colleagues have said is that if you're going to try and type something in more than a couple of times, think about putting into a script so that you can run it again and again and again. So you don't have to keep writing it. Plus, it gives you the ability to actually run the thing with the same commands at the same time, all the time, rather than adding a few things in. So what we can do is when we create a script, it allows us to kind of push arguments into it, variables. You need to make it executable. And if you look at the script format itself, it will always have like a command called a hash bang, this thing here. So as it says here, what we're going to try and do is get the thing to run itself. So what we're going to try and do is just understand the actual script format itself. So at the beginning of the line, you'll have this hash bang list here. But why is it? It's because it's a convention to let the interactive shell know what kind of interpreter to run it. Because when you log into Linux, all that Linux says is interpreting what your commands are and trying to run it. What a script is basically doing is automating that process. So basically you're telling Linux, run this as if I'm running it as an interactive session, but run this by itself. So that line in Linux tells the file that is executed by this. So it's a clean interactive session. So it's not inheriting any kind of weird information that you may have had in your other scripts or in your when your login prompt itself. Now adding this, it tells the OS, it tells Linux itself to invoke the specified shell to execute the commands that follow the script. And what we'll do, we'll cover that in the next section. So what I'll do now is actually go through a basic script that will run. We'll use the text editor. We'll type in a few commands, and then now you can actually follow with me or have a look, and then we can go through it again. I'll just clear my screen. Is the screen okay at the moment to anyone? Do I need to make it bigger, or is it okay?
Yeah, it's okay.
I think
Okay.
it's okay.
Okay. So where am I at the moment? I'm in this directory. So I create a So first thing I would want to do is use a text editor. Now you can use Nano, your preferred. I use Vi as my preferred script, so I'll just use that. I'll just call it first script dot sh. Sh I normally do as an extension, not for Linux, but it's for me to understand it's a shell script I'm writing. So at the beginning, I'll just have to just put in the first line here. And then all I'll do is type in do the standard hello world. And that's it. I'll save the script. Now let's just have a look at the script itself in the sense that if I type in ls-l on the first script, now you see the permissions there. It automatically gives the read-write privileges for me, read for the group I'm in, and read for the other worlds. But as I said before, this value is not actually taken because of the way we've created our home directories. So let's just have a look at the script itself again. All I'm doing here is letting the system know, please run it as a new script, and then run this command echo. Echo in this purpose itself is similar to print if you guys have used it before, or just display on the screen, just the word hello world. So if I run this now, it says permission denied, simply because I've not put an executable on it at this moment in time. So to do that, I use the command chmod, means modify. U is the user place. So if you remember from this is the user section. So I'm trying to tell the system, I have this permission and that permission. So I want to add that. So in order to do that, I need to add the X and then the script itself. So if you now look at if I do ls-l again, that has now changed the executable section. So let's just go through it again. When you first create a script, it doesn't give you executable permission. There are ways around it, but this is the way we kind of advise people to kind of change to add the scripting, because it'll then help with later on when you're trying to submit jobs to BlueBEAR. You then use the chmod function here, this command here with the parameter u, meaning user. So these three here options here, these three, if I can highlight it, are for user account. So I want to add the X, so I've put the plus X sign, first script sign. So if I want, so and then what I can do now is type in first script and runs the command and echoes and runs the script and basically pushes out the word hello world outside onto the screen itself. So does anyone have any questions around the format itself? Because it's simply, we just need to put in the hashbang at the top of the file, and then we can write the script, write whatever we need into that script. So either you guys want to test it out now, we can go through it again, or we can then crack on with the next section, which is the actual workshop itself. Excellent, Zara. Okay, so let's crack on with the next section. Now it's getting you to write your own script, similar to what I've just done itself. So what you can do, you can actually go to that directory which we've listed there, and there's a file called simple script. You can have a look at that and see how it's like. So you can type in Paris, if you just type in escape a couple of times, then so you press escape a couple of times, hit the shift and the colon key, you get this at the end of it, and then type in Q and exclamation mark, and you're in that. But I'd suggest just trying to just use Nano for now, because if you use Nano first script, it's much easier than that. So you'll just to exit, you type in Control Z, Control X, and you're out of it. Are you okay, Paris?
I am still in Vi. I lost you a bit when you were saying how to exit.
Okay, so if you press escape a couple of times first.
Yeah.
Press the, are you using Windows or?
Windows.
Windows. So shift and then colon key. So you should get a colon on the bottom left-hand side of the screen.
Yeah.
Yeah, so as you see on my screen, then type in Q and exclamation mark.
Okay, thank you.
Do we have? Okay, so the next section we're trying to do is just run this section. You won't take you more than 5 or 6 minutes, but we've given you about 20 minutes to do this. So if you can try and create a program and just let me know the tick if you've actually been able to do it. If there's any issues around it, let me know. Richard, are you still stuck in Vi? And then if there's any issues or any other questions, we can then go back to helping individuals out, and the first starting of the just writing a small script. So okay, so going back to the learning outcomes itself. So what we've done, we set up your machines for most of you to accessing BlueBEAR, to log into BlueBEAR, although it being our training server, to create a folder, to manage directories and files, just to understand a bit more about the basic Linux commands. Now, once you start using them, you'll find other commands which you may suit better. You can create a really basic script itself to run, set the permissions for it to be able to run. The next section is all about the other services. Although we have BlueBEAR is the umbrella term, and we've got lots of services underneath it. BlueBEAR is one section of it. So what we're going to do is just explain a bit more about the other services that will actually may help you with your work. So the next step is really, we've just started off on your path to learning a little bit of Linux. Now there's so many other Linux courses available. We've just put a few things in here. So there's LinkedIn Learning, which Debbie said that everyone at the university has access to. You can actually go into that one. This is the one we looked at and we thought it was quite nice. There's also software competence Linux courses. Now they go from a very basic, a very kind of high, mid-level Linux crash course. It's a self-taught stuff, so you can actually go and start doing that as well. The introduction to BlueBEAR, which is our next section for this course itself. This leads on to the BlueBEAR, how to submit jobs, which if you're not already on there, then let us know. We can try and put you on to that course itself, which is, I think, next Friday. Yes, on the 10th. you can find all the information from the BEAR training page itself. It's linked here. Now, we talked about this as well. The other BEAR services, so research data store, this is service you're available to get for each project. The way we define a project is at the basic level is when one supervisor, one student, one PhD student, and now student can now actually include finally undergrad students or MSc students as well. And that's one project, and we can give you up to 3 terabytes of storage there. There's also something called data share. Now, data share is our file and sync tool, which we use similar to Dropbox or any other file syncing applications out there. But this, unfortunately, fortunately, we've had this for about 5 or 6 years now, and we're now retiring because the university has made a massive investment on OneDrive and Teams. You get a lot more for, you get 50 gigabytes with data share, whereas you get 100 gigabytes on OneDrive. However, we're not removing everything around data share. There's something called BEAR data transfer. These are for if you need to really push a lot of data. I mean, you're talking about gigabytes of data from the university to a collaborator off campus, or even just to your own home machine, because especially everybody's working remotely now, and you want to try and move some of this data around to your personal machine, or sorry, to your university machine, you can actually utilize this. But all of these services are available when you access VPN. We do have BEAR GitLab. GitLab is a software versioning tool. So all of those who are utilizing programming or would like some form of version control to make sure that the scripts that they're using at this moment in time are the most current ones. And if you need to go back after you made changes to it, go back and see what changes you've done and why maybe your scripts are not working now. It's a fantastic way of doing it. BEAR Cloud is like a high performance cloud. It's like a virtual machine that you get. So it's more the sense of a prototyping and servicing, whereby your local laptop just can't do the work, but you know that when you want a stepping stone to get onto BlueBEAR, so you want to try and familiarize yourselves with your machines and stuff like that. So you want to play around with something like this. So if you need some high compute around BEAR Cloud, then you can get one of these virtual machines. And then once you start getting yourself used to it, then you can start submitting all these huge jobs to BlueBEAR. BEAR software, we have a free advice help from our BEAR research software engineers. They're able to help in every way, shape, or form. If you're grant holders, you need some computing help in the sense of you need someone to write some code for you, we'll do it for you. Or if you need what we would really prefer would be to help coach you with the work you want to do. So it's more about getting your code up to date so that it's open research. You can, with open research, with data sets out there, you want to be able to show that the work that you're doing is without flaw, and the data that you've received helps with the research and the research paper coming out from it. And also, they're there to help with anything around BlueBEAR. And on top of that, the training. Now, this is just our very basic course, but as we've covered before, there's other courses as well. You can find a lot more about us on this intranet link. For about a year, we've been piloting a service called BlueBEAR Portal. Now, something you may want to use. It's like a web portal onto BlueBEAR. So you can actually use, instead of using PuTTY, you can use a web browser to access your stuff. You can actually get a Jupyter Lab, RStudio, MATLAB starter application, which you may not be able to install on your local machine, so that you can utilize this and submit an interactive job there. Now, as you said, speed is more of the instance. This is more about prototyping. And if you really want to do a lot of work, then you want to try and utilize BlueBEAR. But these are fantastic for kind of getting yourself up to speed and on a familiar kind of browser format. We do help with a lot of special interest groups. The CCB seminars, some of you have attended yesterday. We help set that up. The computational fluid dynamics, if you're interested in finite element methods, MATLAB starter, material simulations. So there's a lot of other people. And if you think that there's a group out there you want to try and build up, there's an imaging group out there which is just starting up. So they're talking to us about helping to set up. Let us know. We can actually help assist you, set up meetings and do the admin work for you guys. As always, help is available. We don't want to start you off the path and say, that's it, don't talk to us now. We are here all the time. You can email us, you can call us, you know, we're absolutely happy to talk to you. We absolutely prefer tickets. This is how we're kind of graded on the university. So absolutely send us a ticket. We can add that onto our list, and one of our colleagues will be able to help you. We can find our regular drop-in sessions, which we have every couple of weeks. We can then, if you let us know you want to kind of have a detailed one-to-one on certain things, and let us know. We can try and find out someone who may be an expert in your discipline or a field that can help you with, whether or not us, whether BEAR champions that we have. You can email, we do have a Canvas courses that we're starting up on. You can have a list there. You can join our mailing list. So we update lots of things. We push out a lot of information on grant funds, interesting things that we may be interested in, other people may have interest in. We send them out and any service problems that we get, we put them out on the email list. We've covered a lot of this stuff, but if there's any questions you guys have got, you want to go back to certain things, let us know. We're here until you kind of get bedded down with Linux.